We're doing our last little section. Remember, we review tomorrow and test on Friday. And this is applications and models, which means that you're just filling in blanks or working word problems.
Is the test going on this 9 weeks?
Yes. All right. In this section, the three angles of a right triangle are denoted by A, B, and C. So big A, big B, and C, where C is the right angle. And if you guys look at the example down here, you can see that the angles are labeled like that. And the lengths of the sides of these angles are represented by the letters little a, little b, and little c. So little a is across from big A or opposite of big A. Same thing with the b, and then little c. The first example says, oh, sorry, where C is the hypotenuse. Solve the triangle shown below for the unknown sides and angles. What do we know about a triangle's angles? Guys, they add to 180. So to find angle B, we can do 180 minus our right angle 90 minus the other angle that they gave us. And when we put that in our calculator, we get 55.8. Now we need to find A and C. You can choose whichever one you would like to. It doesn't really matter, but you're going to base it off the angle A, that 34.2, and you're going to use your trig functions. So if we have this angle, this is our opposite, hypotenuse, and adjacent. We have the adjacent, so we need to use a trig function that has adjacent. Doesn't matter which one, so it's either cosine or tangent. I chose tangent, okay? It doesn't matter. You could have chose cosine as long as it has adjacent. So I did tan of your angle that you have, 34.2. What is your ratio for tangent? What's our opposite? Over our adjacent is? And then how do I solve for A? What is 34.2? What kind of units? Degrees. So make sure we're in degree mode, otherwise it will not come out right. And you said we're going to multiply by 19.4, so tan 34.2. And we get 13.18. Sorry. So now we have this is 13.18. How can I find C? I can do it two ways. I can do it through a trig function, or I could do what? Pythagorean theorem. It doesn't matter which one. I'm going to use a trig function because it's actually a lot less work to use a trig function. So I am going to do cosine of 34.2. Cosine is the adjacent, which is 19.4, over the hypotenuse, which is little c. I've taught you this cheater method a couple times just so you can remember it. When you're trying to solve for something on the bottom, you just switch these two. So what you're actually going to do is little c equals 19.4 over cosine 34.2. So 19.4 over cosine 34.2, and we get 23.46. So again, you wanted angle B, side A, and side C. So what's the first thing I can do on the next one if I want all the sides and all the angles? How do I get angle B?
You said 180 minus 90 minus 20.
90 and 20 is how much? 110. 180 minus 110 is 70. You also could have done 90 minus 20 because you know you have 90 degrees left. So there's your first one. Based off of year 20, here's my opposite, adjacent, and hypotenuse. Same concept, use anything that has the adjacent, so either tangent or cosine. So I'm going to use tan of my 20 degrees equals my opposite, or my adjacent. How do I solve that? So 15 tan 20. Make sure you're in degree mode when I put that in my calculator. I get 5.46, so 15 tan 20. What can I use to get my other one? I can do cosine of 20. Cosine is adjacent over hypotenuse. So 15 over our little a. I'm sorry, our little c. I apologize. What's my cheater method?
Swap those.
Just swap them. So little c equals 15 over cosine 20. Put it in your calculator, you get 15.96. Any questions on that? We have the adjacent side. That's the only one we use. So whichever one you want to start with. You could have started with cosine and then worked your way to tan. Or remember what I said, you can use a trig function and then do Pythagorean theorem. It doesn't matter. But again, why did I choose cosine or tangent? Because we had our adjacent, and those are the only two that I can use. Everybody good? Somebody telling you happy birthday?
What?
Somebody telling you happy birthday
What?
on your phone?
No.
Okay, well, don't be on it. Thanks. All right. Finding the right side of a triangle. The safety regulation states that the maximum angle of elevation, remember we talked about elevations where you're on the top looking, depression is on the top looking down and elevation is on the bottom looking up. For a rescue ladder is 72 degrees. A fire department's longest ladder is 110. What is the maximum safe rescue height? So you have a little building. I like to draw them. I'm a visual learner, so I like to draw them. You have a ladder leaning on the building. So this little section right here is the right triangle that I'm pulling out. Okay, and I'm just going to make it a little bit bigger for you to see. We know that the ladder and the angle of elevation is 72 degrees. Remember, it's from the bottom looking up. What else do we know? So we did the 72. What else do we know?
110 feet.
What is 110 feet? The what? Read it. The ladder. So this is 110. It wants to know the maximum safe rescue height. So what are we looking for? How tall the building is or how high up the building we could go. Perfect. So this is what we're looking for. Compared to the angle, do we have the opposite, the adjacent, or the hypotenuse? Remember, we have two of them. Which one are they? We have the hypotenuse and opposite. What deals with the opposite and hypotenuse? Guys, you need to know these. Sine, watch your mouth. All right, what degree? 72 equals opposite. X over hypotenuse is. How do we solve it? Don't switch it. Just multiply. Yep, just multiply. 110 sine 72. Make sure you're in degree mode. You get 104.5. 0.62. That's it. So draw it out and then figure out what trig function and then solve it. What? Oh, are somewhere not. All right. At a point 200 feet from the base of the building, the angle of the elevation to the bottom of a smokestack is 35 degrees, whereas the angle to the elevation of the top is 53 degrees. Find the height of the smokestack alone. So if you're talking about like a building and then it has a smokestack on top of chimney. Everybody good? So it wants to know both of those. So what's going to happen? Is you're actually going to have two right triangles, a bigger one and a smaller one. Right. So it says at a point 200 feet from the base of the building, base 200. The angle of the elevation to the bottom of the smokestack, this will be the bottom. So we're looking at this building. And then we have a smokestack. Is everybody good? So the base of the building, the angle of elevation from the bottom of the smokestack is 35. Whereas the angle of elevation to the top, this one, is 53. Find the height of the smokestack alone. Now, how would I do that? Just from this little bitty height right here. What do I have to find first?
The height of the whole thing.
The height of the whole thing, and then
And the height of the
the height of the building, and then what do I do to those two numbers?
building.
Subtract them, perfect. So if I'm the tallest one, so the full height here to here, then find this height, and then we can find the difference in those two heights, and that will give us just the smokestack. So let's start with the full building. No, just the smokestack. Just how tall is this is what we're looking for. So we're going to start with the full building. 53 degrees, 200, full building. How would I find that? What two sides do I have compared to the angle? Deals with tan of equals. How do I solve it? 200 tan, make sure you're in degree mode. Gives me 265.41. Doing the same thing. Bottom of the smokestack. We have X, but this time we have 35 and 200. So how does that change the formula? Yep, so the only thing different is it's tan 35. Equals X over 200. How do I solve? 200 tan 35. X equals 0.04. And then what do I do to those two numbers? So 265.41 minus 140.04. 265 minus the 140 gives me 125.37. Any questions? All right. A swimming pool is 20 meters long and 12 meters wide. The bottom of the pool is slanted so that the water depth is 1.3 meters at the shallow end and 4 meters at the deep end. Find the angle of depression in degrees at the bottom of the pool. So I'm going to draw this for you, and I think they give this to you in your book because I wouldn't expect that you would know what this is going to look like. All right, so this is like a side view of the pool. Like if you had a glass side pool, you understand what I'm saying? Like a fish tank, like you're looking in the side of the fish tank. It would have the shallow end up here and then the deep end. The shallow end was 1.3. The swimming pool is 20 meters long. The deep end is 4 meters. It says find the angle of depression in degrees. So that's this angle right here. That's what we're looking for. So we're trying to find this. So I'm going to split this up into just a right triangle. Just a right triangle. This is still going to be 20. But we're only looking at the right triangle because we're looking for the angle of depression. That's why we take off the top part. So how do I figure out this side?
And 4 minus 1.3.
Which gives me 2.7.
Like oh, okay, so you're not using the shower and you're just doing the deep end, and that's why you did it.
I'm just doing this triangle right here because I'm trying to find the angle of depression. You do not, I don't want the distance of the side. What do I want? The angle of depression. So we have two different angles. We have this one and then we have this one down here. We're going to go ahead and find both of them. But your angle of depression should be this one up here. So we're going to find this one first, but then I'm going to talk about that one. So what two sides do we have compared to this angle? Opposite and adjacent, which is? We're going to label these A and B. So tan of A. What's your opposite of A? 2.7. What's your adjacent? How do I do this? Because I haven't had one like this. How do you plug it into this? Actually? We talked about this yesterday. When we had sine y equals x, we changed it to y equals sine inverse x, right? So this one, not sine, but tan. So when you're looking for the degree, you're going to do the inverse tan of that value. Second tan, 2.7 over 20. Make sure that you're in degree mode because we're looking for degrees. So what do we get? 7.69 degrees. Let's go ahead and do the other one. How do I find angle B? We still have opposite and adjacent, right? Look at B. What's your opposite? 20, and your adjacent is 2.7. How do I do that in my calculator? Tan inverse 20 over 2.7. And we get 82.31. Say it again.
You don't have that extra 90 degrees, right?
Say it again.
But the top, the angle of depression is inaccurate because when you want the fact that there's an extra 90 degrees, right?
Why would there be an extra 90 degrees?
If the side of the pool is vertical, and you have to also turn
No, all it wanted was, what was this? Okay, so like if I extended this down, it wants to know what your angle of depression was. So if we're looking for this angle, it's gonna be 82.31. But it said, again, with the bottom of the pool, that's what we were gonna do. The one from the top looking down. So like if you were on the building looking down. Yeah. All right. Flip it. Trig and bearings, these are really hard. They're just hard to think about. So there won't be many of them, and I don't think there's any on your test at all. In surveying and navigation, directions can be given in terms of bearings. A bearing measures the acute angle that a path or line of sight makes with a fixed north-south line. For instance, the bearing south 35 degrees east means 35 degrees east of south. I know that sounds crazy. I'm gonna draw it. I'm a visual learner too. Stop stressing out. All right. So you have north, south, east, and west. South 35 degrees east means 35 degrees east of south. So we're going from south 35 degrees to the east. I don't know why they don't just use like southeast, blah, blah, blah. It's just the way that they do it. Okay. So again, right here, you can see that 35 degrees east. How do you know that? Because see the arrow is pointing towards east of south. What would this one be? Start with your degrees. 80 degrees. What direction is it going? West. And where did it come from? What?
Like the first one, why would they not just write it like southeast? 305?
I don't know why they don't do that, but they don't when they're talking about bearings. I guess so they know what position they're coming from and which direction they're going. I don't know.
Okay. I was thinking about compass. Like, that'd be
Right.
southeast
So it's,
305.
yeah, so it's a little bit different than just having a compass or like latitude and longitudes. It's just how you're going. All right. Yeah, I don't know. So look at the next one. What's your degrees? 45 degrees. We're headed east from north. All right, so I know the next figure is really, really dark. I apologize. Usually they're really light. A ship leaves port at noon and heads due west at 20 knots or 20 nautical miles per hour. At 2 p.m., the ship changes course to north 54 degrees west. Find the ship's bearing and distance from the port of departure at 3 p.m. So on this, we're going to be looking for C. I'm going to redraw this for you so you guys can see it. So don't stress out. So we have one big right triangle and one smaller right triangle. There's your labels, A, B, C, D. C is your 90 degrees. DC is little b. You have a straight helping line right here. And this angle is 54 degrees. This is all in the picture, so don't think that I'm getting it from nowhere. From A to B, is 40. And I think that's all the picture gives you.
20 centimeters from being.
Oh, yeah, thank you. So this side is 20. Thank you. Sure.
My contacts in it.
All right. So if you guys look, they gave you a helping line. Anytime they give you a helping line, you are going to use it. So the reason that it's there, we can find this angle. Does everybody see what I highlighted, that little angle right there? Because what is this angle? Pull all the way around, 90 degrees, right? So how do I get this little bitty angle right here? So 90 minus 54, I don't know why I'm not doing it in my head. It's all good. Gives you 36. So this angle is 36. So now I'm going to redraw little B, C, and D. This angle is 36. We know that that hypotenuse is 20. We don't know what little b is. How do I figure out little b? What two sides do I have compared to the angle? So this is your opposite. This one is your hypotenuse. So I'm using, what's our angle? Opposite over 20. How do I solve it? 20 sine 36. Which gives you 11.76. The reason that's important is so I can get the bottom. I need the bottom as well. Solving this whole triangle. How do I get the bottom? You can do cosine. Cosine of 36 equals, how do we do cosine? Adjacent. We don't have adjacent. That's this little d right here. Over hypotenuse is 20. How do I figure this out? 20 cosine 36. Little d is equal to 16.18. All right, what else? What do we need to find essentially? What did I say we were looking for? This big long hypotenuse, right? So now I'm going to take the big triangle, which is A, C, and D. I know that this is 90. What is CD? 11.76 CD. What about CA? And then how can I find little c? I can do Pythagorean theorem. What else could I do? Do I know what any of these angles are? I do.
90 degrees.
Can you use the 90 degree? No, you cannot use the 90 degree because you never use the 90 degree in a trig function. You use the opposite and the adjacent from the angle of reference.
Oh,
Okay, because then it wouldn't be the hypotenuse. It would be the opposite. Does that make sense? So Pythagorean theorem is the best thing to do because I don't have the angles. I could find them. I'm too lazy to. Are you good or no?
Yeah.
So this is 36, so we would find this one, and then you can find that one. It's too much trig functions, too much trig functions. All right, put this in your calculator, 11.76 squared plus 56.18 squared. Gives me 3294.49. And then how do I solve? And we get that C equals 57.3976. So there's the distance from the port. What else did it ask me to find?
There,
Okay. What was the bearing in? It was in what? Here's bearings. What are bearings always in? Degrees. Okay, so I need to find the degree. Which degree do I need to find? Say it again. The A, yeah. So I need to find this now. I can use any trig function that I want. And the reason I can use any trig function I want is because I have all three sides. But I'm going to use tan. So we're going to do the bearing now. Why would what? Because that's where you're from here. That's the degree that they're looking for, the ship's bearing and distance from the port. So here was the port. How far did they travel? What was the traveling? All right, so tan A equals, what's your opposite? And your adjacent? How do I put that in my calculator? I tried, there's paper in the way. How do I put it in there? So second tan, 11.76 over 56.18. Gives me that A equals 11.82. But we're coming from a 90 degree. So we got to subtract it from the 90 degrees. That's exactly why. Why is it 90 degrees? Because it's like our coordinate plane. It's coming from the 90. So how far did it go from that vertical mark? So the north or south or whatever. So again, look at it one more time. What angles do these make? 90-degree angles. That's why we're subtracting it from 90 to figure out how far we went from that 90, from that straight line. Does everybody see that? All right, so what do I get? All right. So it says the ship changes course to north 54 degrees west. So your bearing is going to be the same thing. North 78.18 west. Again, there's not really any like this on your test. We're just going over it so you can see that you had it. Okay, do not stress out about that. It's going to be the easy ones like fill in the triangle. The periodic nature of trig functions is useful describing the motion of a point on an object that vibrates, oscillates, rotates, or is moved by wave motion. For example, consider a ball that is bobbing up and down on the end of a spring. Suppose that 10 centimeters is the max distance the ball moves vertically upward or downward from its equilibrium, which is at rest position. Suppose further that the time it takes for a ball to move from its max displacement above zero to its max displacement below zero and back again is t equals 4. So to take that one, if you're thinking about a yo-yo, from the time the yo-yo is at the top of your hand till you drop it and it comes back up to the top of your hand, that full motion. Does everybody understand that? That's exactly what it's talking about. is 4 seconds. So it takes 4 seconds for that yo-yo to come back to you. Assuming the ideal conditions of perfect elasticity and no friction or air resistance, the ball would continue to move up and down in uniform and regular manner. If we had like a spring and we were holding it up and we let it go, so like a slinky spring, and we didn't have gravity or anything like that, it would continue to just oscillate. That's what it's saying. So if we didn't have all that stuff, it's going to oscillate. From this spring, you can conclude that the period or the time for one complete cycle of the motion is 4 seconds. I just told you that. So again, think about the yo-yo from the time it leaves your hand till it hits the bottom and then hits your hand again. That one full cycle was 4 seconds. Its amplitude, the maximum displacement from equilibrium, it told you was 10. And its frequency, the number of cycles per second, I'm sorry, equals 1/4 cycle per second. Why? Oh my gosh. How long does it take for a cycle? 4 seconds. How many times? You guys see it? 1 cycle per 4 seconds. Does that make more sense? Seeing it like that. Motion of this nature can be described by a sine and cosine or sine or cosine. Why? What does a cosine or sine graph look like? What's it look? Yeah, wave, right? So it continues, it keeps that wave going. Motion of this nature can be described by that function and is called simple harmonic motion. If you take physics, you'll work with simple harmonic motion. We're almost done, I promise. We're not doing any problems with simple harmonic motion. We are almost done. It says definition of simple harmonic motion. A point that moves on a coordinate line is in simple harmonic motion. It's my fault. When its distance d from the origin at time t is given by either d equals a sine, and then you have the lowercase Greek letter. We talked about omega t. Or, and you can put anything there. It doesn't matter. You could put xt, you could put beta t, it doesn't matter. D equals a cosine. Where a and your little w, it doesn't matter what you call it, are real numbers. Such that that is greater than 0. Which means it has to be positive. The motion has amplitude. We already learned absolute value of A. A period of 2 pi. I think we had B. So sine bx minus c. You guys remember seeing that? So the same thing. I told you you could use any number or letter you wanted to. But the frequency is the opposite. W over 2 pi, or that little omega over 2 pi. And then we're not doing any of the problems on that. Like I said, you're not going to have any of those on your test, and it's really beyond what we need to do. So your homework, there should have been 2 problems again. We're not doing it. Make sure you label it. Page 336. I'll be telling you a number. 6 through 24 and 34. You have close to 40 minutes. You should finish.